All right, one of these clocks says it's 9 o'clock, so I'm gonna get started. How's everyone's weekend? I'm sure it helped if there was no homework in here. That will be changing. But I'm hoping that today we can get through everything that is left here. Maybe that's a little bit ambitious, but we will see. So we are finishing off the last couple of methods in our singly linked list. These errors will finally go away as we actually implement everything from the interface. And the next thing to implement is an iterator. We'll talk about exactly what that is, motivate it, why we need it, and then we'll go through and implement it. So we have a whole set of tools. These will be all of the tools that you will need for the first assignment that will have you doing something very similar to this. You will have access to all of this code as you do it. You will be basically remaking this concept for a doubly linked list and a circular linked list. So we'll talk about those differences as well. But we all want to use the same interface as we do it. We'll be implementing it to implement the interface as well as iterators for both the doubly linked list and circular linked list. And then I have a challenge problem that will be extra credit. And that will be some of the methods that I want you to implement are some of the methods that have historically been on the APE. And one of those I'm going to make harder than would ever show up on the APE. And I will have you, for extra credit, be manipulating the types of nodes. So for instance, if I wanted to add a bunch of nodes from a doubly linked list to the end of a singular linked list, then you would need to convert all of those doubly linked nodes into singular linked nodes. So trying to figure out when do I need to do that, as well as how do I convert between node types, that will be something that is interesting. And I'll be curious to see how you solve that. I might be able to give you a couple of hints to make that a little bit easier, but that will be the extra credit. Not required, but if you really want to dabble around with this and get familiar with utilizing this code in some way, then that'll be an option. Question? Yes, yeah, that's the idea, is that you get experience working with this code. So you need to now know how to be able to call these methods, how to be able to change between using the structure that this is. That can help you to understand what is that structure, how does it work as you do more complicated things. Everything that I do, there has to be some tie this early in the class to something that either builds skills on the APE or gets you practice with questions that have historically been on the APE or that use skills that will show up on the APE. I'm very APE motivated. I ordered the APE ball. I think I talked about this last time. So that will be in my office, hopefully sometime this week, in case you want to come test your fates in a way that has no correlation or bearing on how you will actually perform. All for fun. All for fun and fun for all. All for fun and fun for me. Something. All right, so last time we were just getting started with this remove function. The goal of this is to take in some generic value and start looking through the linked list to say, I want to remove the first instance of this element that exists in the list. So if this is a list of integers, if this query is the number 15, we'll be looking through node after node after node saying, does your node contain a value 15? Does this node contain a value of 15? Until the answer is yes. Once the answer is yes, we want to remove that node. If the answer is no, we get all the way through the list without finding it. That is when we return false from this method. So any thoughts about how we might want to accomplish this? We have a couple of exception types that we've handled, but yeah, let's go ahead and sure. Okay, yeah, we don't want to make a new node, but we need some node that's going to, what is that node going to represent? Starts out as the head, it's kind of a query node, the node that we are asking, is your value the value that we are looking for? Yeah, we need something to access some current node, and we need to set that to be the head to start off. So we will do that, we'll make a singly linked node. We don't know the type yet, so we have to tell it that it's the generic type. what do we want to call this? I've historically called this something like either cur for current or query, since we're actually asking the question of this node. Are you something or other? Does anyone have a preference between current or query or some other idea of something that is very descriptive that represents what this node is going to do for us? Current? I'll call it cur. We'll set it out to be the head. Again, we're not using that keyword new. We're not making a new node. We're just giving a new name to an existing node. The node that we currently know as head is also going to be able to be known as cur, at least until we modify where cur is pointing. Excellent. Anything else that we're going to need as we do this? Yeah. Some kind of loop. So we're going to be modifying, moving next. Once we identify the node, is there any work that we've done that we wish we would have done when we get there?
Previous node.
Some kind of previous node? Yeah, when we find that value, we need to modify the prior nodes next. And since we're not in a doubly linked world, there's no way to go backwards. So it would be nice if we had some way of keeping track of the current node as well as the last node that we visited. We want to make this easy on us, or do we want to make this easy on the computer? There's always a push and pull there. Let's actually show what it's like to be easy for the end user, because this will allow us to make use of something that we have done before, but it also creates a nice opportunity to talk about efficiency. So let's jump right into the loop. We can say, how do we want to say this? So inside of this condition, what we really want to do is want to compare the value of wherever current is pointing to the value that we are looking for, this element that we passed in. Yeah.
I said, well, cur.data does not equal element.
Cur.data does not equal element. This is interesting because we don't know exactly how we are comparing these elements. If this is a primitive, which we know it is not, then we could use something like equals or not equals. However, if this is a complex type, how do we compare an object to another object? Yeah? We could look for null if we were trying to find something like the end of the list. We're trying to identify if the node's contents is the same as the contents we're looking for. Yeah. Yeah, we need to use some kind of dot equals. So all objects have an overloaded. Is this object equivalent to? Do we know the difference between equals and dot equals? Is that something worth going over in more detail? Close. Let's actually go through this. This is a very important distinction, especially in Java. It becomes very easy to get confused. So we have an object. We have two different names for this object. On one hand, we're going to call it head. On the other hand, we're going to call it cur. Both of these point to the same linked node. Doesn't really matter what this is. Let's just say this has an X with null. If I say what would we expect the value of head equals cur to be? True or false? True? That's correct. Why?
Same reference to location.
Yes. The actual location of this stored in memory is the same. And that is what equals compares when we're looking at objects. On the other hand, let's say this has an actual value. We said this is 15 with a null reference. Now we have a second node that has 15 and a null reference. One of these is going to be head. One of these is going to be cur. We say head equals cur. What do we expect?
False.
False. They're not the same node. Even though those nodes have exactly the same value, have exactly the same next reference, null. So by all intents and purposes, these are equivalent to each other. Yes, that's not what this is asking. It's not asking, are these two objects equivalent to each other in every sense of the word equivalence, except for where they're stored? Basically, is this a clone of that? We would want to be able to ask the question, is this a clone of that? Because if we pass in a value 15, and we want to eventually be able to say, do both of these nodes have 15 as their value? This here is not actually, the 15 is not really stored here if we think about how this node is set up. There's a generic here, and a generic itself is an object. So while I will occasionally draw this 15 directly in here, this is not storing an integer. It's storing a reference to another object. So what's really happening here is we have references to some primitive 15. Really, it's an object that contains the value 15. And since these are stored in different locations, even though they have the same value, this equals is going to be false, even though what we're saying is we're storing integers. We're not really storing ints, we're storing integer objects, which is different in Java. Question?
Equals work the same way when comparing primitive data types. So say
Yeah, it's
743 and 743. Is it checking that it's in the same memory location, or is it just comparing?
if it's an object. Only if it's an object is it comparing locations, because objects are all references that store a location.
So is a primitive like int an object?
They are not. They're something that is separate. So works on any primitive type. So ints, doubles, chars, anything that starts with a lowercase letter. As soon as it starts with an uppercase letter, even if it is the class integer or double or character, those are objects. So we need to use some kind of dot equals, because that's what the object exists for. So if we say something like head dot equals cur, this is why you have to overload this dot equals whenever you have an object that you don't want to behave in the default way. This dot equals can define what it means for objects to be equivalent, even if they're at different aspects, they're different places in memory. We can say how we identify a node is we look at this value. So now we're not looking at this as a reference, we're going to say this dot value, what is that? This dot value, what is that? Now, rather than looking at this as an equals, now we can say basically, we can define this to say if head dot, what do we call this as a node? In our node class, we called this a particular, we called it data. So I'm going to use that. If head dot data, and again, this is protected and in the same package, so we can do a direct call here without needing a getter. If we couldn't do this, then if we set them to be private, then we would need to write a getter to be able to access this. Be head.getData. So if head.data equals, because again, we don't know what this type is. This is something of type T. When you make it generic, you have to be very careful about using equals versus dot equals. Here again, we want to use dot equals because this isn't an int, this is a generic T. So if head.data equals cur.data, so we'll let this say, are these equivalent rather than are they at the same location? And we also need to check the reference. So and head.next. Now head.next is a node reference. A node reference is going to be a location. So we could use equals here because the location is just an int. Still somehow safer to use dot equals here. And last time we mentioned, if we have some desire to write an if statement, if this return true, else return false, you can just return the value of this Boolean. So the overloaded dot equals for these two nodes would just be to return the value of that Boolean expression. These are the two components that we need to determine whether these objects are equivalent. Are these data points equivalent? And are these next references equivalent? If they are, then they don't have to be in the same place. They're functionally identical to each other. The same thing as actually cloning yourself. You can see that these aren't the same object, but no matter how deep you look at them, they're equivalent in every facet, except for their location. Questions about that? Does that make sense? So dot equals for objects, equals for primitives. Ends up being very useful here. Okay, now I feel like we're ready to understand what goes inside of this while. So as we write this while, we're going to need to use dot equals. So I'm going to say, well, not cur dot data dot equals the value that we are trying to search for. Does this make sense? So we're just checking whether the value in the node cur is equivalent to the value that's being passed in as a parameter to this method. Are these both 15 or whatever else the T type happens to be? Now we can generically say it doesn't matter what the instantiation of this T is. If it's a person, if it's an airplane, if it's an integer, it doesn't matter what it is, we can now compare it with its dot equals. This is why overloading dot equals is so important. Is it allows us in something like a linked list to be able to compare objects when we don't know what the object's type is. Very important. So while this is not true, we want to continue to look at the next node, look at the next node, look at the next node. So we could just say, look at the next one. When this is done, we still don't know where the previous is. How could we structure this in a way to be able to reuse something that we've already done to save ourselves some time, regardless of thinking about its efficiency? What could we do? Yeah. Yeah. Yeah, so the challenge of implementing this is we don't have a place for previous until the first time through this loop. We basically have to check, can we move to the next node after the head? If we can, the first time, move the node, then move each node forward, current and previous. If we could just keep track of where current is, we have something that can find previous. Yeah.
How I would do it, not a while loop, use a for loop, and then that's your keeping track of I, and then you can call the remove that's already there.
Yeah.
Index.
Yeah, so we could do something like set a, we could even say, so this is the index that we're at, we'll set it to 0 as we're looking at the head. And then we could just bump up index as we do this. This tells us the index, where in the linked list is our query. Is it at position 4? Is it at position 9? Whatever position we happen to find that at, we now know that index such that when this loop terminates and we have found where that is, then we can call find node before. We know it returns a singly linked node. We can now call this the prev node that we've been calling everything so far. And we can just set that to find node before, and we pass it the index that we want to find the node before at. This will do it. But I mentioned that there was a little bit of a concern here with regards to efficiency. What is that concern? How does find node before work? It starts back at the head. Right, so if we think about this. As we have. Some head and eventually we reach. The prev. And the node that we're trying to reach, and now it doesn't matter. What we're doing from here. Basically, the issue is if we set them both to be this node, then the first thing we have to do is query. Can we move to the next? First of all, is this the query? Is this what we're looking for? If it's not, is there something after here that I can change to so that the previous now points to the node before, then repeat the logic over and over. Or we can say, let's just iterate until we get to cur, set prev back as the head, and continue until some index is less than this. Is one more work than the other? It ends up being more work. There are more conditionals that we have to check. But it turns out that it's in the same order. As we start talking about computational complexity, we will start talking about mathematical orders of functions, as well as what is efficient or not efficient in terms of what is allowable in certain circumstances. So since this process is the same order, we're doing about twice as much work, or it's bounded by twice as much work. That ends up for the most part being okay, because it doesn't change as this program, as this list scales in size. It doesn't change much. So something like this wouldn't be the end of the world. It's not going to change the order of how quickly this is done. Is it bleeding edge efficiency? No. But it has not changed in a meaningful way. It has not changed the order of the amount of work being done. We'll go into a lot more detail about that in a bit. Yeah.
Are you saying that to traverse the list once, right, to set current to where we want it?
Mm-hmm.
And traverse the list twice, to set previous where we want it? Are you saying it's the same amount of work?
I'm saying it is
Right.
more work, but it is not meaningfully more work.
Okay.
If something ends up being twice as much work, regardless of how long the list is, we are going to say that is okay.
I was saying, is it still twice as much work for just, if we traverse it once and still have to set?
Right.
For,
Now, it would be more work if for every node along that, we had to do something to every node before it. So now this list is 50 long. I have to do something to node 1, then node 1 and node 2, then node 1, 2, and 3, then 1, 2, 3, and 4. That is more work than twice as much work of going 1, 2, 3, 4, 5 up to 50, and then 1, 2, 3, 4, 5 up to 49. That ends up being meaningfully more work as the list size scales. I just want to plant that idea of more work versus less work, because we're going to be exploring this in a lot more detail as soon as we are done with linked lists. All right, so this to me is okay, because it reuses something that we already wrote in terms of development time. When you have a tool that you've already written and it doesn't change the order of how something is going to run, then it is okay to reuse that work. On the other hand, if it does make meaningfully more work, the general expectation will be that you minimize the order of the amount of work being done. Questions on identifying the previous? Yeah.
So the final, well, we have that as protected. So someone who's making our program cannot access it. We can
Correct.
this. What if we want to make it so that someone can want to do is access to that?
Just turn it to be public. So we wrote the find node before here as private, which says that find node before can only be called from within this. If we set this to be public, now it appears as part of our API, or it becomes something that we need to support in our API. because somebody can use it, we need to document the how to use it. But if it is private, then it is not meant to be used by them. They don't know it exists. It's just a helper function for our program. Yeah, great questions all around. However, we've also already written a remove at an index. Is there even more that we could save? If we wanted to be able to remove it at an index, have we identified the index that we want to remove at? So we could even save identifying the previous and manipulating the previous if we just reused an even more abstract something that we already wrote. So what if instead of even finding the previous, we just called remove on the index that we found? What does that return? That returns a Boolean that says whether that was successful or not. What could we do? Yeah.
Just return that.
Return remove index. So this returns a Boolean. Remove index is going to return something. The issue here is that we did return a T here. It returns what we. So I think close. We just need to say. Say we're going to return this removed value. We first need to go get it. Then we want to actually return whether this was successful or not. Do we want this to be a Boolean or do we want this? We already know the T. That was our reasoning. The user is passing in this. We don't need to return that. We just need to determine whether that was successful. Is there a way to condense this onto a single line? Anyone familiar with it? Yeah.
Say return.
Yeah, so we can say. How do you state it exactly?
Said remove next dot equals.
We said index dot equals. So this is an int.
Might have to do that outside, but.
Yeah, so one thing you can do is you can do an assignment inside of this. So let's actually do this assignment. We can say T equals remove, and we'll pass in the index that we want to remove from. This is going to return something. We want a T result. And now we can surround this as we're checking for whether this was successful or not. What is the check for whether it was successful? If this remove is successful. Yeah. That's going to be slightly difficult. Is there an easy way to talk about it being false?
I'm gonna try catch.
Thinking we can do it in one line, and honestly, it's not worth the time that it's going to take to craft it to be exactly perfect. So I'm just going to basically do this and then return true. And now, if this doesn't work, then we could utilize our own exceptions, and we could use something like a try catch. Why don't we do that just to see how that works? So we will surround this call with a try. As we do this, then we can catch whatever exception we would expect comes from this. So why don't we then catch, let's say, remove can throw either some illegal argument exception if we do that catch, then what is it that we want to do? We want to return false from this. So you could do something like this. If an illegal argument exception happened while we called remove, then we're going to return false. Otherwise, we are going to return true. Yeah,
So we were going to do what we were doing, but we want to, increase the size as well. Or the size of the.
yeah, we will certainly need to handle something about the size of the list here as well. Yeah,
Doesn't the size of the list go down in the moving though?
yes. When we call this remove, we would have to be careful. Because if this is successful, we already decremented the size. It's a great point.
Is there any point to having that assignment of the result value to that removed index then if?
Yeah, because we're not actually using this, are we? We don't have to return the result. However, this does need to return something. It does return something, and we could just throw it away. Right? You don't have to store the result of a method call if you're not planning to use it. However, it also becomes a little bit more confusing and it looks like a bug if it's returning something and you're not doing something with that. So if this is something that you would either want to comment that says throw away the return value because we're not planning to use it or something. There's no real correct way to handle that, just some way that is clear that someone reading this code knows that you know what you're doing, or that's something that you've seen coming. Yeah,
So instead of doing that try catch, couldn't you do return element dot equals remove index?
yeah. You could, and that would be a little bit shorter. I'm gonna keep it as a try catch, and the reason is I want to show an example of try catch somewhere in this code in case you want to catch any of these exceptions in your own. Just to have an example of that embedded in the code, but that is a good one-line solution. Questions on what we've done here? Is there anything else that we need to account for before we leave? Yeah. No, it's outside of the loop ends here.
Oh,
Once we've identified where the current is, we want to remove the current. If it was inside of the loop, then we would be trying to remove everything. Yeah, that would be difficult. Is there anything else that we need to account for? Are there any side cases to this remove that aren't the same as the side cases inside of that remove that we're calling? Yeah,
It never finds that element, will the loop just keep running, eventually hit null?
yeah, so. We say not cur.data equals element. Is there a way for this to fail to terminate? Yeah, we never find this. Eventually cur is null. So maybe we'd want to add a secondary while that says here, well, cur is not null. But then we also need to check once this loop is done, is the index the tail? Did we go all the way past the end? We could, inside of this, just say if cur is null, return false. We weren't able to remove it, this element, because it wasn't in the list. Questions on this? Thoughts on this? Yeah,
Would the try catch block not throw an exception and index was null?
yeah, we ended up with that. The issue is this loop ever going to terminate? if cur is null. We set cur equal to cur dot next. I don't want to do that. Cur dot next doesn't exist because cur is null. We get a no pointer exception. So I think we need something in the loop that tells us, because otherwise we might be able to crash our program from within the loop, which would be bad. But I agree that if we could somehow move on to remove from that point, then remove with throw that exception. But I would argue we're not even gonna get there. How we doing? Question?
What happened with the element you're trying to move is on the head?
The element we moved is in the head. So we initially set cur to head. We would check cur dot data dot equals element. This would return true, so it would immediately terminate our loop without doing any of the loop guts.
Correct,
So then we would call remove at index 0.
correct.
Because we declared this index outside of the loop, it's gonna exist outside of the scope of the while. If we did this as a for, then we would have had to declare the index, so we wouldn't have had to, but we could have made the mistake of declaring it's inside of the for loop. That means it's local to the for loop. We wouldn't have access to the index outside of the for loop, which is why it makes more sense for this to be a while rather than a for. Yeah,
Would we have, would it be smart to, well, check if we put current people in the whole. Return something to the user that says pass value is not on the list.
we could add a different type of exception from this that says not in the list.
Run it again, like try again.
Yeah, anything that would just say that that's why this didn't work, that's probably better than just returning false, it didn't work. Yeah, we could certainly look whether cur dot next is null. The question then is the tail, if we're trying to remove something that exists at the tail, once we're at the tail, cur dot next would be null. So we want to do that after we check the current value. If we check the current value and then look to say, is the next null, then that would work. So there is a way to make it work for sure. We just have to be very careful there that we make sure that we're not accidentally leading us to not be able to remove the tail, which would be an easy bug to introduce.
You said that before when makes sense in this circumstance, but you could use the int I instead of declaring the different integer. And that means in the if loop or in like if statement inside the for loop that you do the remove. And that
Right.
means you go through the for loop and it doesn't do anything, then you just return false.
True. You could move all of this inside of the loop. When you find it, immediately handle it, as opposed to breaking out of the loop and then handling it. Yep, you could do that. As always, there are lots of ways. I actually like that way a lot. That's probably the way we should refactor this into, but for time, I'm gonna leave it for now. I do like that solution. Yeah, right here, dead code. So this just says that there's no reason that this exists. Because cur can't be null inside of this statement. Yeah, there's an issue that we haven't checked whether cur is null. We're assuming in this while cur equals cur dot next. I agree, this actually doesn't solve our issue now that I'm looking at it.
Should we put it underneath the solution?
Yeah, I think that we should check the next cur. As we bump up, we'll say cur equals. Yeah, maybe it does make more sense here to check. We don't want to make this change unless. This was the point from before. The issue is this will stay stuck pointing at cur. I'm gonna fix this offline and make it actually nice. But I do want to move forward here and make sure that we have a chance to talk about iterators and what they're for. So we basically have everything now for this, assuming that this works nicely. And there's one quick change I'm gonna need to make to this. Has anyone seen or heard of an iterator before? Or know what it does? Yeah, yeah, you've heard of it? So not very many people. The reason an iterator exists is because if you're going to do something that involves modifying a list while you are iterating through it, the math changes. Let's take a look at an example of that, or why that would be. So we have, we'll just make a nice short linked list. I like 3. There are 3 elements in this linked list. And then we go off and dwindle where. What happens if I were to write something like a for each loop that said, let's actually give these values. For each node, if that node's value is even, remove it. We would want to write some kind of for each loop. So you would imagine that you could do something like for, I'm just going to call this single linked node and in our list. If, and I'm going to assume this is a list of integers. Unfortunately, I have to do this slightly differently, but if we would say n dot value mod 2 is 0, then list dot remove. Since this is the first time we're seeing it, we would say remove n, and this would just remove the, I guess you'd like to keep track of the, the value. So this would work calling our value t, assuming that that t is instantiated as an integer. So something like this. What's the issue with this? Or can anyone see an issue with this if you were to try to execute this? Yeah.
The size of the list.
It changes the size of the list. It changes the indices of the existing nodes. Right? This is currently index 0, 1, and 2. If in the middle of this, we identified a node that we wanted to remove, at the very end of that process, this would be pointing over here, and this would now be index 1, because the size of the list is now 2. But we just finished the work for index 1. The next thing to do is check index 2. Are we ever going to check whether this node's value is even? Probably not. What if it happened to be even? What if I wanted to remove it? So you can see that there's a little bit of work that needs to be done to make sure that we are doing what we need to be doing so that this actually works. Whenever you are modifying a list inside of an iteration, that is the purpose of an iterator, to make sure that you can use the iterator to do that, rather than straight up using something like the list and a for each loop. So iterators have the following methods. They always have a next, a has next, an add, and a remove. Those are the 4 methods we're going to want to write and dictate, assuming that we are in the middle of something. We want to return now something like the index to check next, to make sure that we are able to set up so that if we do add or remove in the middle of the list, what do we do next, so that we can successfully do those things. Questions on that concept? Anything I can help make clear? All right, so this is actually going to be a brand new file. We're going to make a new class, and what do I call it? Something like linked list iterator. I'm actually gonna call this list iterator. It'll actually work for the most part, regardless of what kind of list we make. The idea is that we're going to want to allow for different iterators for all of the different linked list types that we want to work with. I'll start with just a list iterator. This is going to be an implementation of an iterator, and it turns out that there is an iterator interface that we can use. So we're going to implement the existing iterator generic. So this does exist, but I am going to have to import it under util. All right. I did forget, this should also be parameter-based. All right, so now it will be able to tell us exactly what we need to implement. So we need a next, we need a has next, we need a remove. I think add might be optional for this. With the last few minutes, let's think about how we can set this up. So fields, it turns out that we're going to, I think we can make these private. We want a few different things. How do I want to structure this? I think we want something for our current position and something for the previous position. And we can either call this pause for position, where are we? Or cur, we'll come up with that decision here in a second. We also want the list that we are trying to iterate over. So this is going to be a singly linked list that is our list. So these are going to be our fields, nodes that are the current and previous, and a list that is the list that we're trying to iterate over. So we need all of those things. Diving into the constructor for this, we're going to construct we're going to say that this is going to take in the list. When someone wants to make an iterator, they will need to make an iterator over an existing list reference. So it should take as a parameter the list, and we will just say can we just say something like this? I think this is fine. Let's say pause is no, let's say prev is no. We'll set these when we need to. We may come back and change this. Yeah,
Why would you use this before those two?
since there's no ambiguity of which they're referring to, the only time that there is, you're absolutely right that it wouldn't be a problem to add the this dot. But because I passed in a parameter list, it became necessary to distinguish the ambiguity of which list is here by saying this dot list equals list. When I say pause, there's no local pause. There's nothing was passed in as a parameter, nothing that's been defined since then. So it can only refer to the field. That said, for clarity, we can do it either way. We are unfortunately out of time already. 15 minutes flies, so we're gonna have to implement this tomorrow. I will go make some change to our remove and make this actually clean, something that I'm happy with. And I'm gonna go start some office hours for a couple of hours. Feel free to come meet with any questions or concerns you have. And I think I will get the assignment out today. It'll be due a week from Wednesday, lots of time. Just so that you can start thinking about it. Don't do too much work with it until we have all of the code fully written. See you all tomorrow. I don't.